Hello, my name is Alan Willen. This is a video to cover a script I wrote for DSU's CSC 842 Security Tool Development. So this is EmojiObf, meaning obfuscation. So the idea is to provide the ability to take text or arbitrary data, encode it within emoji, and then on the other side, decode that data. I kind of was inspired to write this after working with my other script and thinking about different types of encoding and ways to encode or obfuscate data. The idea behind this one being that emoji are, although they are dense and costly character data, actual data wise, so these are generally UTF-32, so they don't take up less space than the original input. However, they are relatively innocuous and they are dense visually, as in a single emoji has more data available to be encoded into it, and they are less likely to be noticed in a context where you're attempting to send a short message. So the script allows you to encode the data in different ways and attempt to obfuscate without directly using encryption. So as a very basic example, we could encode hello. So what it does is it takes the emoji starting by default at character Unicode code 1F600, which is around where smileys start. It takes the type of encoding we're doing, so by default text encoding, so it picks emojis to fill a dictionary from 00 through FF. It will skip ones that are not valid emoji, and then it will encode each character as that specific emoji. So in this case, it is a one-to-one encoding. And then on the flip side, we can decode that data. So I can take the entire line, so the script automatically discards anything that isn't emoji, and will also discard emoji that aren't in the dictionary. So we additionally have the ability to do some of my favorite things where we can specify using other base encoding. So base 16, base 85, those are exactly what you would expect to be, where the input text is encoded using Python's base 16, 32, 64, 85 encoding, and then those resulting characters are encoded into emoji. One distinction is that the dictionary that gets generated, rather than from 00 through FF, the dictionary is the size of the encoding scheme. So for base 16, there are 16 characters in a base 16 alphabet. So the emoji dictionary has exactly 16 characters in it, which is why in our original example where we used hello with a 00 through FF dictionary, we got cars which are relatively high in the alphabet because H is something in the 70s or whatever it is in ASCII. Whereas in base 16, the dictionary chose 16 very early characters, presumably 1F600 through 1F0F or 1F60F, and so the resulting characters were all smileys. Similarly, the base option, so we can adjust. So by default, we can see again that this is what the default is. So if we adjust the base to be, say, 1F700, we change the set of emojis. So two different users of the script can generate different output even with the same input message based upon what encoding scheme that's chosen. Considering that this could be used for very short messages, so in cases where a user wanted to covertly send another user a message and wanted to do so through social media, Facebook, Twitter, Instagram, whatever, they could essentially concoct a post or a series of posts that happen to involve those emojis, and a witting second party who knows that those emojis are part of an encoded message and know the combination of options necessary to decode them can do so. And again, because emojis are so very commonly used in social media, it would be somewhat difficult to actually notice that this is being used unless you actually know what's going on. Additionally, I have created a encoding scheme that actually does a similar to base encoding. It takes the given alphabet, determines how many bits are actually necessary to encode that data minimally. So the custom alphabet that's shown here, which is just simply A through Z, that only actually requires 5 bits to encode all characters. So hello is encoded into 5-bit characters plus an end of message plus padding. That is then sliced into a width. So the script internally creates a dictionary that covers all of the bits that you would want to use within an emoji. So it's essentially using the least significant bits of the emoji in the same way that the bits in the base encoded characters are. So this allows more compact. So the default hex encoding, it's a 1-to-1. Base encoding is an expansion. So base 16 is generally 1-to-2. The other bases are somewhere between there. This custom encoding actually compresses it. So you can see that the input was 5 characters, the output was 4 characters. If we add on to that, so we've added another 2, 4, 5 characters. So we have 10 character input, and it looks like we got 8 characters out or 7 characters out. So this, in some cases, this might cause some difficulty to how do you select text to surround this output with to obfuscate it within the message you're attempting to send. But I think it is a unique and novel way to attempt to covertly communicate with someone over an untrusted medium like social media. So normal users will see the overt message. Witting individuals on the other side could then derive the value they need to derive from the overt message that you're posting online. Additionally, there are some convenience functions like the ability to input a actual file. So if I believe there should be help here or readme. So although this is obviously hot garbage, you can, very hot garbage in fact, you can specify a file rather than text, CLI text as the input. So this could be helpful for both the encoding process if there's a larger amount of data, or automating so that you're using this tool to feed output from another tool, as well as for the decoding process. So I could imagine a case where you take the user's posts time sorted, just dump all that text into a file, and because this script throws away non-emoji and emoji outside the dictionary, you could just feed all of that data into the script and just let it decode that data naturally. For the custom encoding that I designed, By default, the string.ascii lowercase is used. The user can specify other string library. So if you're familiar with Python, the string library has a number of alphabets defined there naturally. The user can use one of those or specify their own. So ASCII lowercase by default does not have space or punctuation or anything like that, which is part of the reason why it can be encoded in so few bits. But if you know that you only need lowercase and maybe certain punctuation, or if you're, for example, only encoding malicious data, so imagine a world where you are a malware controller and your malware is looking for certain types of Twitter posts for tasking. So if your alphabet is only digits or only certain types of commands, so for example, if your malware only had 6 or 7 commands it could do, that's a very small space, right? Like 7 commands, you can easily encode that in only a couple bits. So I think this allows for a lot of variability, such that even if I know that someone else is using the tool, based upon what combination of features that they choose to use, it becomes very difficult, even knowing that someone is using it, and even though the tool doesn't naturally do any encryption on its own, the obfuscation is very difficult if the message is so small. So it's a very small message like hello or help, or just a few short words spread over some amount of time. That's very few characters to attempt to do a frequency analysis, especially if you can derive a message, or I'm sorry, if you can create some way to communicate that you're rotating different aspects of this. So like one day the seed is this, next day the seed is that. You could communicate that via another channel, or pre-communicate like a shared key, or like a symmetric key on either side. So I think that this is a interesting and novel way to short message, do covert communications over an overt channel, again, like social media. So, thank you very much. I hope you enjoy the tool.